So I have been asked to answer, define and explain the processes of frequency modulation and phase modulation differences. Frequency modulation, the carrier amplitude remains constant, while the carrier's frequency is changed by the modulating signal. As the amplitude of the information signal varies, the carrier frequency shifts in proportion, which says that as the modulating signal amplitude increases, the carrier frequency increases, and vice versa. The amount of change in carrier frequency produced by the modulating signal is known as what is called frequency deviation. Maximum frequency deviation occurs at the maximum amplitude of the modulating signal. The frequency of the modulating signal determines how many times per second the carrier frequency deviates above and below its normal center frequency. If the modulating signal is 100 Hz sine wave, then the carrier frequency will shift above and below the center frequency 100 times per second, which is known as frequency deviation rate. With no modulating signal applied, the carrier frequency is a constant amplitude sine wave as its normal constant center frequency. Assume a carrier frequency of 50 MHz if the peak amplitude of the modulating signal causes a maximum frequency shift of 200 kHz. The carrier frequency will deviate up to 50.2 MHz and down to 49.8 MHz. The total frequency deviation is 50.2 minus 49.8, which is equal to 0.4 MHz or 400 kHz. However, the frequency deviation is expressed as the amount of frequency shift of the carrier above or below the center frequency. Therefore, the frequency deviation in the example given in the book is said to be plus minus 200 kHz. This means that the modulating signal varies the carrier above and below its center frequency by 200 kHz. The frequency of the modulating signal determines the rate of frequency deviation but has no effect on the amount of deviation, which is strictly a function of the amplitude of the modulating signal. Moving on to phase modulation. Phase modulation is another way to produce angle modulation. How does it do? It varies the amount of phase shift of a constant frequency carrier in accordance with the modulating signal. The resulting output is a PM signal, phase modulation signal. Imagine a modulator circuit whose basic function is to produce a phase shift. Remember that a phase shift refers to a time separation between two sine waves of the same frequency. Assume that we can build a phase shifter that causes the amount of phase shift to vary with the amplitude of the modulating signal. The greater the amplitude of the modulating signal, the greater the phase shift. Assume further that positive alternation of the modulating signal produces a lagging phase of phase shift and negative signal produces a leading phase shift. If a constant amplitude, constant frequency carrier sine wave is applied to the phase shifter, the output of the phase shifter will be a PM wave. As the modulating signal goes positive, the amount of phase lag increases with the amplitude of the modulating signal. This means that the carrier output is delayed. The delay increases with the amplitude of the modulating signal. The result at the output is as if the constant frequency carrier signal had been stretched out or its frequency lowered or decreased. When the modulating signal goes negative, the phase shift becomes leading. This causes the carrier sine wave to be effectively speeded up or compressed. This result is as if the carrier frequency had been increased or increased in frequency. Phase modulation produces frequency modulation. Since the amount of phase shift is varying, the effect is as if the carrier frequency is changed as well. either if the phase shift if the modulating signal goes negative or positive, the phase shift also changes from lagging to leading, which also cause the frequency to increase or decrease. Since PM produces FM, PM is often referred to as indirect FM. Moving on, how does PM and FM differs? It is important to point out that it is the dynamic nature of the modulating signal that causes the frequency variation at the output of the phase shifter. In other words, FM is produced only as long as the phase shift is being varied. In FM, maximum deviation occurs at the peak positive and negative amplitudes of the modulating signal. In PM, phase modulation, the maximum amount of leading or lagging phase shift occurs at the zero crossing of the modulating signal. Recall that we said that the frequency deviation at the output of the phase shifter depends upon the rate of change of the modulating signal. The faster the modulating signal voltage varies, the greater the frequency deviation produced. Because of this, the frequency deviation produced in PM increases with frequency of the modulating signal. The higher the modulating signal frequency, the shorter its period, and the faster the voltage changes. Higher modulating voltage produce greater phase shift, which in turn produce greater frequency deviation. However, higher modulating frequencies produce a faster rate of change of the modulating voltage, and therefore also produce greater frequency deviation. In phase modulation then, the carrier frequency deviation is proportional to both the modulating frequency and the amplitude. In frequency modulation, the frequency deviation is proportional only to the amplitude of the modulating signal regardless of its frequency. The relationship between carrier deviation and the modulating signal characteristics is summarized in this. So that answers the question, the process of FM, PM, and their differences. I hope you guys understand and like this video. Thank you.